Hi everyone, my name is Tesla. I'm a 2025 ACD Fellow, and today I will be performing a Western blot. So Western blots are 2-day protocols in our lab. They can be done in 1 day, but we prefer to do them in 2. So first we have to do is make a gel. So there's 2 different gels that we make. One's called a stacking gel, the other's called a resolving gel. We make a resolving gel first since it goes in the bottom of the gel, and that's where our samples run through. And then we have our stacking gel, which goes on top of that once it is solidified, and that's just so our samples can even out before they we are just making the 2 of them here. Yes, so we make our 2 gels. There's a lot of different components in them. And then we add 6 mils of our resolving gel into our casting system here. And then you see how there's bubbles there. We use something called isopropyl alcohol, which evens out the top. And that way we won't have any bubbles. And now I am making tubes for my samples to go into. So here we add our buffer, which denatures our protein so that it runs in a line, because proteins are normally all squiggles or folded onto themselves. So this way it runs nice and through our gel. So I'm just doing those dilutions here to add the proper amount of sample to our buffer. And then we spin them down because there are some bubbles in there, and we boil them for 10 minutes at 100 degrees. So while those are boiling, we can see that our gel has solidified. I dump off that isopropyl alcohol, and then we can finish up our stacking gel, which goes at the very top. So this is where we add our comb, is what it's called, and those little divots of the comb, so those green bits there, will make the wells for where our sample goes into. And then we make running buffers, so we dilute our 10 times to 1 times there, so that's just what I'm measuring there. And since our samples are done boiling, we take them off and we spin them down to reduce any steam that's at the top. And then again, we have to keep everything balanced, so I leave one in there while we spin the last one. And then we can get our gel ready in our running system. So we saw that it was solidified, and we put it in our little casting system here. And we can add our running buffer now. We add it to the middle, and then it overflows. We take out our comb once the liquid is in there because it is easier and the gel doesn't tear. And then they're really hard to see, but we add our samples into our wells with these special tips that are really nice and long so we can get to the bottom of our well. And I have a full gel here, so I have 10 samples. And then we run it 100 volts until it passes through. And this is me prepping our transfer. So I am making our transfer buffer here. After our gel runs, it goes through something called a transfer to go into a membrane. So here I am soaking the materials that goes in there. So we have some thick paper, we have some sponges, and then we have our special membrane for our protein to transfer onto. And then I had some issues with the casting system. It broke halfway through, and that's why it was curved. It should be a straight line through, so hopefully it doesn't look too bad in our imaging. But we take it out and we take off the glass plate. We cut where that stacking gel was, so we only have a resolving gel. And then we prepare our transfer sandwich. So we start on the black side, we add our sponges, our filter paper, we add our gel onto there, and then our membrane. I cut off the sides of the membrane if it's a little too big between it and the gel, just because if there's any overhang, it can create bubbles between the two, and then our protein doesn't transfer over properly. So after I cut, I put on more of the special paper and I roll out any potential bubbles that are between the membrane and the paper. And then we add our sponges there and we can put it into our transfer casket. So black side goes to black, and then we have a little extra one in here just to keep everything nice and tight in there. So we can add our transfer buffer on top and we put it in this dish since we have to pack it with ice. So once it's packed with ice, we go to our cold room. If we don't pack it with ice or put it in our cold room, it gets so hot that it can melt our gel. So that runs for an hour. And here I'm making 5% skim milk. So this is just instant skim milk powder with a detergent and buffer. So this works to block our membrane. And what that means is that we don't get any off-target signal. So we are only getting what we want to see, basically, what our antibodies that we put on should image. So once it's done in there for the hour, we take it back to the lab and we disassemble the sandwich. And here's where the moment of truth comes. We want to make sure that our protein successfully transferred onto our membrane. So as you can see there, there is the ladder. That's all you'll be able to see. We add our milk to block for an hour. And then this is an old primary that I had. It has antibodies for AGAT, GAMT, and then our internal control to make sure that the same amount of protein was added into each well. So after the hour of it blocking, we can add the primary antibody mixture. I'm going to label it, and then we can put it in the cold room. So we put this in the cold room for an hour overnight, in the cold room overnight, and we come back in the morning. So it goes on its shaker, and then for day 2, we come back in the morning and we grab it. We go all the way back to the lab and we do what is called washes. So first, what I do is I collect all of that primary from our blot, since we can reuse this 3 times. So I put it back in there, and then I make sure the membrane stays moist, and then I mark that this has been now used another time, so we know in the future. It goes on the spinner for 5 minutes, and during that time I'm going to make our secondary antibody. So this is what shows up our AGAT and our GANT that we had originally put on. So these are light sensitive since we are using an infrared technology to image them. So that's why they're in these special little bags. After the 5 minutes, we can dump off the water and add more, and then it washes for 10 minutes. After that, we do one more wash for another 10 minutes here, and then we can add that secondary on there. So that secondary incubates for an hour at room temperature on the shaker. And then after an hour, we can take that and just dump that one off, and then we wash it again for 10 minutes for 3 times. So that's just what we're going to do here. And I think I missed one of the washes there. But after the 3 washes of 10 minutes each, we go all the way up to the upstairs where we image it. So we go up a floor and go to the room that has all of the technology in it. And then this is the imager here. So we've placed the membrane face down so those bands go towards the glass. And then we put on this little silicone sheet and we roll everything out so there's no air bubbles. And then this is the software where we image it, just getting set up here. So this takes a little while to image. I have sped it up for you guys, and then the analysis takes a long time. So I haven't done it for this blot, but I want to show you guys an example here. So the bottom portion of the blot here, we can have our AGAT at the top, our GAMT, and then our actin. And we can see that our AGAT protein is seen in our knockout treated mice, which is so exciting. It's seen in the liver just because the liver is a sink for gene therapy like AAV viral vectors. That's why there. Thank you guys for following along and have a great day. Bye.